This is a video for students that missed the Shop Possibilities Day or maybe just want to review the information. This is the electronics section. So this is the circuit you're going to build for your lamp. It has two functions. It's an analog and a digital circuit intended to teach you a little bit of both. And so you'll have a switch, and in one direction you'll have super bright white LEDs, and in the other position you'll be running RGB LEDs, which are programmable and can do a number of different things that you choose for them to do. So to explain what is analog and digital, so analog is a process of moving electricity through in which the operation of the circuit is really determined by the components and their connection and their configuration. Whereas a digital circuit is using very specific voltages, and the operation is primarily determined, at least in our case, by programming. So we've got a programmable part of the circuit and then an analog part of the circuit, which is the white lights. So how does it, first of all, just a little bit about circuitry. So we'll be talking about this, but there's something called voltage, which is an electrical pressure that pushes electrons through the circuit. So in our case, the analog part, we've got some resistors going to LEDs, which are hooked to negative. So we're pushing electrons through, and it's then known as current. The current goes through the LED, and the circuit has to make a full circle back to negative. So we have some resistance so that we get the right amount of current to the LED, and then we have our current, and then our voltage is the pressure that actually pushes the electrons through. In our digital, we're running the digital circuit off of the same voltage. We're going to run it off 5 volt. In fact, the entire circuit will run off 5 volt. And then, so the circuit is hooked to both positive and a ground or negative connection to run. But then the actual thing that it's running isn't determined by necessarily what components are connected, but by what program we put inside. So the central unit here is known as a microcontroller. Now, you may also, in this class, hear it referred to as an Arduino. So it's got some software on it that will run Arduino code. So we preload it with software so we can program it in the Arduino environment, which is a C environment that has made programming devices rather accessible. Although it may not seem super accessible at first, and it makes it far more accessible than programming small devices like this in the past. Some other parts on the circuit. To run the microcontroller, it is a computer, so you have to have a small item here known as a crystal. This is a clock that allows it to keep time. We have a little resistor right under here that keeps it from resetting over and over. There is a pin that would allow us to have a reset button. We're not going to use it, so we just hook a resistor there so it won't reset constantly. We have a little test LED over here. It's just a small red LED that we can program to just flash maybe once when we turn it on or whatever, just so we can troubleshoot if we need to. And then we've got a small resistor coming out of one of the legs going to this strip of 5 RGB LEDs. These are addressable LEDs. That means that each one can be given a number, 0, 1, 2, 3, 4, 5, and we can tell it specifically which LED we want to be what color. So we can have them be any combo of colors anytime. So you'll be able to program it. And so these are all in a row, as you can see. It's possible to separate them out as well. You are going to be soldering them underneath, and so how much space there is between each LED is up to you. You can put long wires between them and spread them out, but they do all have to connect back to this microcontroller. We have a few other little small components. These are little capacitors. They're filtering capacitors, so they filter the power so that it runs properly. We have a little micro USB connector here, and so that just allows us to get power. Yours is actually going to be down here. This is last year's circuit board. Yours is going to be reconfigured down here. And then we have a small programming header that's right here, these pins, and so that allows us to connect a small connector here and via USB hook it to the computer, and we can program it. Now, when you're thinking about this in your lamp, there's a few things to consider. One is the circuit board itself. So the circuit board here, the overall dimensions, it's about 3 inches by about 2.75 inches. And then if you look at it this direction, if you were to count the height of the LEDs, which you could extend off the board, but if you were just to build it as you see it here and including the switch, you're looking at a little more than 3/4 of an inch tall. In fact, with the switch, it's almost an inch tall. So whatever I design, I need to figure out like where is the circuit board going to go. Now it's possible to cut the circuit board down and modify it. I have seen students do that. I've seen students cut the sides off and then connect things together manually. This definitely will make your process harder. If you can keep the circuit board as one, it's definitely going to make it easier, but it is possible. It would be possible, for example, to chop off the entire top of the circuit board if you really needed to make it smaller, as long as you didn't cut it in the microcontroller. So that's an option. Some people also, so right now, if you're going to run this thing, you're going to be turning it on and off with a switch that's hardwired into the circuit board. So some students don't like that, or it doesn't fit their design, because technically this is inside your lamp. You need a way to turn this on and off, maybe a panel that opens, or maybe just a hole that you can reach in and flip the switch. If you don't like that, it is possible to extend the switch off of the board and put it elsewhere in the lamp. So instead of soldering it directly here, we would have wires that extend it off, and then it goes somewhere in the lamp. So that's something you'd want to plan for before you solder your circuit together. Another thing you got to plan for is how are you going to power the circuit. So we offer two options. So one is this USB chargeable battery. So this is just a lithium battery. You can charge it from your computer or from the wall or whatever. So if you choose this option, you get the small short USB and you get some kind of battery. It will look something like this. It won't be bigger. It might look a little bit different. And so I could charge this up. Once it's all charged up, I can run my circuit with it. So these are pretty common little batteries. People carry them around to charge up their phone or whatever. So this would run your circuit. So it depends on your program and a few other things, but it's probably going to run your circuit for about 10 hours. It could be a little more than that, but it would probably run continuously for about 10 hours if you just never shut it off. And then you got to recharge it. If you don't think you're going to really care, if you don't care about a portable lamp, the other option we offer is just a wall plug. It's still a 5-volt system, so we'll give you a longer USB cable, something probably in the 6-foot range. You can get one of these little plugs, and then you'd be able to, using the same socket, just plug it into the wall. So you will get to choose that. It's good to plan ahead for that, because if you're going to do the battery, you got to figure out where in your lamp this is going to live. Or is it just going to hang out beside the lamp, which may or may not look good. So think about that. That's your power options. Let's see. Okay, another thing is, so if I do store this, if I do choose the battery and it's inside the lamp, how am I going to access it? Because I've got to get inside there and charge it sometimes. So, keep figuring out, is this going to be removable from some part of the lamp to charge? And that's something to consider too. In some ways, designing around the battery is going to be more challenging. That doesn't mean you shouldn't do the battery, but just figure those things in. Either way, well, okay, so if you do the wall plug, the other thing you got to think about is this is going to have to extend out of your lamp so it can actually go to the wall. So there's going to have to be a hole somewhere in your lamp that's at least wide enough to fit this through. And then also, even though this socket is actually going to be over here, this is going to stick off your board. It adds close to an extra inch on the board just with this thing sticking out. So in one dimension, I need to plan for this cord coming out. Even if I choose the battery, this is going to stick out. And so that's going to add a little more dimension to the circuit board. Let's see. Yeah, so one thing to mention is that both these are 5-volt. I did say that. This circuit is designed to run only off of 5 volts. So you cannot find some other random power supply and try to hack it in here. It's got to be, you can run it off of any, this is a 5-volt battery, run it off any kind of phone charger or anything, that's fine, but it needs to be something that goes from a USB mini connection or a USB micro connection to the circuit. Okay, a couple other things. You got to think about the placement of your LEDs. So as we build the circuit, you'll have an option to place these LEDs wherever. So I've already mentioned you can take this RGB strip and you can extend it out wherever you want. You could extend it to a completely different part of the lamp. So maybe part of the lamp lights up white and then a different part lights up different colors. You could program your RGBs to be white if you just want more white light. But these two will never light up at the same time. That's just the nature of the circuit because it's an analog and digital. This is the analog setting and this is the digital setting, and they actually light up separately. If you really wanted them to light up together, I could show you a modification so they both light up together, but then you wouldn't be able, they would always light up together. So that would be a special modification. Okay, so these white lights could also be extended off the board. So if you wanted to take them and just extend them off the board so that there's different lights in different parts of your lamp or whatever, that can be done. So all these are extendable, right? I'll tell you this though, extending the lights definitely will add more time to your building process. As it is now, these are little sockets. I do 2 solders, I plug my light in, I got a resistor done. If I extend these off, I'm going to have 2 wires. I'm going to have to solder both ends of the wire. Then I'm going to be putting this in a small clamp and soldering the wires to this little LED. So it's definitely a more time-consuming process. You need to be ready to just put a little more time into your circuit if you choose to do that. Let's see, what else? You can extend them. Yeah, so one last thing here is that just the importance of soldering. So we're going to be, underneath here, we're going to use a soft metal to permanently attach the pieces on the board. We'll start with what's called a breadboard. The breadboard is just a space where you can plug parts in, and so we'll prototype our circuit here and get it working, and then we'll map it out and transfer it to this board. And we use the circuit mapping tool, which I have here, which just is a picture of the circuit board, and then we map it all out before we solder it. But once we solder it, the key here is actually being super neat and really getting good solders, really precise solders. If things connect together that aren't electrically supposed to connect, your circuit won't work. And so we'd have to desolder it and so on. So being that for many people it's going to be your first soldering experience, is trying to, not do extra things if you don't feel like you need to this time around. Is really try to just focus on the base circuit and really try to get it nice and solid. We will do some soldering demos and we'll do some soldering exercises, but soldering is often the key to it working really well or to an extended troubleshooting process. So that's really about it to think about in terms of this circuit and how it's going to go into your lamp. So hopefully this information will help you.